Okay, example 1, 22 plus -5 plus 8i minus 9i.
That's the one that was, for a second, I thought it was like a J, but it was backwards.
Oh.
Upside down question mark.
No, it's an I. I just make it curly so that it doesn't look like a 1. Okay, so when we're adding and subtracting complex numbers, the first step is to get rid of parentheses. So you always look in front of the parentheses to see if there's anything that might change what's inside. Right now, there's just a plus sign. That's not going to change anything. So we can just drop the parentheses. This becomes 22 minus 5 plus 8i minus 9i. Once you've got rid of parentheses, you just combine like terms. So 22 minus 5 gives us 17. And 8i minus 9i is negative I. Technically negative 1i, but if the coefficient is 1, you don't have to write it. Once you have combined like terms, you just need to make sure that your answer is in standard form, which means the real part is first and then the imaginary part. So right now, these are already in the same order, or in the right order. Real part and then the imaginary part. So this is our answer.
See, I was that way too. I was seeing people go to California and I can't even afford to go to the grocery.
How did the softball girls get? Yeah, I have a question about this. How did the softball girls get a game to the beach, like on the beach? How was
Well,
how is that possible?
They entered a tournament.
What the
I
crap?
had psychology with, Robin
That's
Dalton.
freaking
She
nuts.
was sick because I guess they lost. Everybody's playing like crap, so they can go to the beach.
Them.
I got that.
3/4 plus 7/5 I minus 5/6 minus 1/6 I. Okay. So getting rid of parentheses, this first set of parentheses, there's nothing in front of it that might change anything. So we can just drop the parentheses. 3/4 plus 7/5 I. The second set of parentheses has a minus sign in front of it. That minus sign is going to change the sign of everything inside. So this becomes minus 5/6 plus 1/6 I. Okay, now we can combine like terms. We have 3/4 minus 5/6. No. And 7/5 plus 1/6 that we need to combine. Now you could, if you're going to do it by hand, you could do that. Change the denominator and add the fractions, or you can use your calculator. So on these graphing calculators, and it should be the same way on the app that you guys downloaded at the beginning of the year on your Chromebooks, you can do alpha y equals to insert a fraction. So we'll do 3/4 minus 5/6. We get negative 1/12. Okay, then we have 7/5 I plus 1/6 I. So we do 7/5 plus 1/6. 47/30 I. It's not a very pretty fraction, but that's what we get. Your calculator is always going to give it to you in the simplest form, so you don't have to worry about simplifying the fraction that your calculator gives you. Okay, so check that this is in standard form, which means the real number comes first and then the imaginary number. So we have this in the correct order for standard form, which means this is our answer. I also want to show you, in case you don't want to use one of these graphing calculators or the app on your Chromebook, if you use a different calculator, just make sure that you put each fraction in its own set of parentheses. Like if you're going to do 3/4 minus 5/6, it needs to look like this. The other thing about doing it this way is that your calculator is going to give you your answer as a decimal that you then have to change to a fraction. However, you need to do that on whatever calculator you're using. So if the problem is given to you in fractions, your answer needs to be in fractions. There'll be a couple practice problems that are already decimals to begin with, and those can stay as decimals. Here's example 3. We're going to start looking at some multiplication. -3i times 6 minus I. So to multiply and get rid of these parentheses, we distribute -3i to both terms. So -3i times 6 is -18i. -3i times -I. Multiply the coefficients. So -3 times -1 is +3. And I times I is I squared. Okay, if you think back to the notes that we took, we talked about how I squared is equivalent to -1. So anytime you end up with an I squared while you're working these problems, you need to replace it with -1. So we have -18i plus 3 times -1. So that changes to -18i minus 3.
Now we need to put standard form.
Yes. So we've done all the math that we can do. Now we just need to make sure our answer is in standard form, which means the real part comes first and then the imaginary part. Right now, our imaginary number is what is first. So we need to switch these around to be -3 minus 18i.
Wait, so if we have a squared letter, it automatically.
If it's I,
If it's out.
This is not hard.
Only if it's out.
right?
Okay.
Because I is not technically a variable. It's a constant. It's the square root of -1. So when you square I, you get -1. Couple more examples. Example 4. Right, we have the square root of 14 plus the square root of 10i times the square root of 14 minus the square root of 10i. So we're multiplying two complex numbers together, and we can use FOIL to help us remember how to multiply these. So first, the first terms, the square root of 14 times the square root of 14 is just 14. Here's a little reminder of the math behind that. If you have the square root of 9 times the square root of 9, well, the square root of 9 is 3, so that's technically 3 times 3, which is 9. Yeah, if you're multiplying two square roots and the number underneath are the same, then you're just going to end up with that number as a whole number.
So the one would be 10i.
Well, close. If we're using FOIL, which you don't have to use FOIL, I just have always used it, so it's the easiest for me. So we multiplied the first terms. The O in FOIL would be the outside terms, which would be the square root of 14 times the negative square root of 10i. Those are the terms on the outside. So we have a positive times a negative, which is a negative. And then this time the numbers underneath the square root are not the same. So the square root is going to stay, and we just multiply the numbers underneath. 14 times 10 is 140. And we still have an I on there as well. The I in FOIL is the inside terms, which would be square root of 10i times square root of 14. That is a positive square root of 140i. And then the L in FOIL is the last terms. So the last term in each set of parentheses is the square root of 10i times negative square root of 10i. So we have a positive times a negative, which is negative. We have the square root of 10 times the square root of 10, which is just 10. And we have I times I, which is I squared. Okay, now we can combine like terms. We have negative square root of 140i plus square root of 140i. That equals 0, so these cancel out.
The 10 would turn to a positive, right?
Correct. So that leaves us with 14 minus 10i squared, but I squared is negative 1. So that makes this 14 plus 10, which is 24. Last example, number 5. Four plus 5i squared minus 4 minus 5i squared. Quick reminder, 4 plus 5i squared is not equal to 4 squared plus 5i squared. If it's an exponent, you can't just distribute it like you might do if we were multiplying something in front of this parentheses. So this is not how we work these. To do 4 plus 5i squared, you have to expand it. 4 plus 5i times 4 plus 5i. Squaring something means you're taking something and multiplying it by itself. Then we're subtracting 4 minus 5i squared, which is 4 minus 5i times 4 minus 5i. Okay, so now we'll use FOIL on these as well. We have to do it twice, actually. So in this first one, if we use FOIL, 4 times 4 is 16. 4 times 5i is 20i. 5i times 4 is also 20i. And 5i times 5i is 25i squared. Okay, so now we're subtracting. We're subtracting everything that we get when we multiply these two complex numbers together. So since we're subtracting everything, we need to put parentheses around what we get. If we didn't use parentheses, it would only look like we're subtracting whatever first term we get when we multiply, which isn't true. We're subtracting all of it. So we use parentheses. Okay, 4 times 4 is 16. 4 times negative 5i is negative 20i. Negative 5i times 4 is also negative 20i. And negative 5i times negative 5i is positive 25i squared. So because we're subtracting all of these numbers, we need to distribute this minus sign to all 4 terms. So it's going to change the sign of everything. We'll leave these terms at the front alone for now. So we get minus 16 plus 20i plus 20i minus 25i squared. Okay, now we can combine like terms. We have 16 minus 16, well, that's 0, so those cancel out. We have 20i 4 times. 20 plus 20 plus 20 plus 20, that's 80i. And then we have 25i squared minus 25i squared, that's also 0, so those cancel out. And 80i is our answer. Any questions on these 5 examples? Okay, I'm going to get some practice problems posted. Okay, those of you on Zoom, I just got it posted to Google Classroom, so you can get started on those. I put the due date as Thursday at midnight. I think you can get it done in the time that we have left in class today so that you don't have to worry about it. But if for whatever reason you're working on it later and you have a question, I wanted you to have the opportunity to ask me over Zoom when we get started on Thursday. But you will not have time in class to work on it Thursday, so don't be counting on that. Okay, let's go ahead. You guys stay. Well, no, you can leave the Zoom if you want to. Just make sure if you have questions that you email me or you hop back on and I can help you.